All right. So this is going to be the second lesson of 0.4 nth roots and real exponents. So today we're going to be looking at what a radical means. Okay. So over here they show that that square and square root are inverses of each other. Well, it's really there you go. So they are inverses of each other. Okay. And then if we do that, then there's this property here, the same base property. Okay. So these have the same base, they're equivalent to each other. So that means their exponents have to be equal to each other. And then they solve for n, and it turns out that n is 1/2. So what they did is they showed that square root of b is the same as b to the 1/2 power. All right. And the same thing applies for all radicals, okay? It depends on what the index is. Remember, for a square root, our index is an invisible 2, okay? And that's where that 2 comes from. Now, on the next slide, we're going to see what happens if we have different indexes. So let me put this on the notes first. If b is a real number, variable, or algebraic expression, and m and n are positive integers, the greater than 1, then b to the 1 over n power is equal to the nth root of b. If the principal nth root of b exists, and b to the m over n is equal to the nth root of b to the nth power, or the nth root of b to the m. Alright, so what does that mean? It means if we have x to the 1/5, that's going to be the same as the 5th root of x. So that denominator in the exponent is the same as the index. So again, if we had y to the 1/9 power, that's going to be the 9th root of y. And you can actually find that on Desmos. So on Desmos, there's that button. I think it's right next to the square root button. It's the nth root. Okay, so that's how you can plug that into the calculator. All right, but now some calculators, they don't have that nth root button. So this is why this is really important. Because if you use one of those calculators that don't have that button, you need to remember that the nth root or the 9th root can be written as to the 1/9 power. So 1 divided by 9. Okay. And I can show you how to do that on the calculator if you want. And then, so that's that. Now, if we have a numerator that's something other than 1, all right. So if we have x to the 2/3 power, this is equal to, remember, the denominator is the index, and the numerator is the exponent. Now you can write it like this, or you can write it like this. This is what they're saying, cube root of x to the 2nd power. So this numerator can be the power of everything, or power of just the radicand, the power of just the inside. Okay? And yeah, let me give another example. 1/5/7. So 7 is our denominator, so that goes here, that's the index. And then the 5 goes on the outside. Or 7th root of y to the 5th power. Same thing. Depends on how you like to write it. Okay? That's it. So let's take a picture of that, put on the notes. And if anybody else is watching these videos, I apologize. But if you do want to see the notes, just let me know and I'll give you the link to the notes. All right. All right, so we're going to do some examples. Yay! Where we're simplifying. Now, this simplifying part, we have to remember some of the properties of exponents, some power properties. Okay, I'm going to put it over here. Power properties, or properties of exponents. Okay, and I won't go into too much detail on these because, yeah. So here we have, this is the product property. Product means multiplication. Okay, so product property, it says if we have powers with the same base, and you're multiplying them, then all you do is you just keep the same base, so 2 become 1, and then you add the exponents. And there you get x to the 8. All right, and if you want to see why, so x cubed is x times x times x, and then x to the 5th is x times x times x times x times x. And yeah, how many x's do you have? Are you multiplying all together? 8. All right, so that's where that comes from. So nobody wants to write them all out, so just add them. Add the exponents. Okay, and now we're going to talk about the quotient property. We talked about multiplication. Now let's talk about division. So quotient property is, let's do y this time. Y to the 7th over y to the 4th. Okay, so this one is going to be, so if product is adding them, if product is adding the exponents, quotient dividing is subtracting them. Okay, so again, the bases have to be the same. The bases have to be the same. And we subtract the exponent. 7 minus 4 is 3. And if you want to see why did I write y to the 7th? Now I have to write 7y. There you go. And then on the bottom we have 4y's. Cancels out, cancels out, cancels out. So those are all equal 1. Y divided by y is 1. Y divided by y is 1. And what are we left with? 3 y's left. There you go. Okay, now I'm going to talk about something. Should I do it now? Yeah, that's fine. So now if your denominator is bigger, the exponent in the denominator is bigger, you're going to end up with a negative number. So it's always the numerator minus the denominator, always. So 4 minus 7 is going to give us y equals negative 3. Now remember, a negative flips it to make that exponent positive. Okay, so there's another way to do this. We can go over that later. Okay, and yeah, there's an easier way, faster way to do that, and I'll go about that later on in the year. And then we have the power property. So here is where we have z. Let's say z to the 4th to the I'll just do second. I'm thinking ahead this time. Okay, so z to the 4th to the 2nd power. So whenever you have the two exponents separated by the parentheses, or you have the power of a power, what you want to do is, that's the same as multiplying. So if you multiply the two same base, you add the exponents. If you divide the same base, you subtract the exponents. If you have a parentheses in between the two bases, in between the two exponents, you multiply. Okay. So here it's going to be y z to the 4 times 2, which is z to the 8. All right, why is that? Because z to the 4th is 2nd power, that means z to the 4th times z to the 4th. And that tells us we have z to the 4 plus 4, which is z to the 8. Okay. And there we go. All right. Negative exponent. So let me take a picture of this. So you have to remember those properties. Good properties. You're going to use those a lot. All right, so here, so hopefully you like fractions because we're going to do math of fractions. Yay. All right, and it's okay because all the bases are the same. So, except for over there, but that's fine. So here we want to do it one at a time. Okay, so let's focus on the top first. So here, notice on the top we have b. The bases are the same. We have b for the base, and we're multiplying. When you multiply, you add. When you multiply, you add. When you divide, you subtract. When you have parentheses, you times. Okay, so it's 5/4 plus 3/4. So here, since it's a fraction, since the denominators are equal, you just add the numerators, and you get 8/4, which is b squared. All right, so that's a numerator. Yay. Let's block that out. And we just have 1/4. Okay. Can't really do anything at the bottom. The denominator. Okay. Now in hindsight, I realized I was too quick, too hasty to simplify that 8/4. Let's go back. Okay, why are we going back? Because our denominator here in the denominator is 4. And this one is 4 also, so we need to have the same denominator. So let's do these. So the bases are the same. And then when you multiply, you add. When you divide, you subtract the exponents. So 8/4 minus 1/4. And 8 minus 1 is going to give us 7. And there you go. Is that how they want us to write it? Yeah, it's okay. They said this or write it out. So b to the 4th root of b to the 7th power. The denominator is the index, and the numerator is the exponent. Okay, so either way is fine. For me, I like this. Yeah, because fractions are fun. All right, so notice for 18, we have multiple ones. Okay, whenever you have different bases, what you want to do is you want to do it one at a time. Okay, don't get scared. Say they're all different. That's okay. Yeah, just do one at a time. Do the coefficients first. So we have 2 times 3. So 2 times 3 is going to give us 6. That's it. All you got to do. And now we're going to look at the x's. We have x to the 4th times x to the 4th. So when you multiply, you add. So x to the 1/4 plus 1/4. Then you get x to the 2/4 or x to the 1/2 power. All right, done with the x's. Now on to the y's. Tell me why. Okay, so here, oh, we used red already. Purple. We're gonna do the y's. Again, we're multiplying, so you add the exponents. 1/3 plus 2/3 is 3/3. And 3 divided by 3 is 1. Yeah, you don't need to put the 1, but if you want to, you can. Yeah, usually you don't. That's it. Yay. Now, if you want to write it out with a radical, notice that the x is the only one that has that fraction of an exponent. So that's the only one that would go inside of a radical. And remember the index, the denominator is an index, but we don't usually put a 2 for square roots. It's invisible. Okay, so either one works. Either one works. All right. I am going to take a picture of that because I do not have space for the other ones. To kind of sum it up, at least how I interpret it, is that when you said white man, you mean the stores that came over from Europe. They themselves are an all right. And feel that they have the power. Okay, so next thing, let's do 19. If you want to try 20, feel free to. I'll leave that one up to you. Okay. So here we want to do our properties of radicals. That's where we split it up, remember? So we have, oh, do they want us to do it this way? Okay, let's do it this way. So you could split it up. And you do it one at a time, or you could do it this way. You can write that parentheses because I do want to show you to you this way. Parentheses, and that radicand is 648 cubed. And we're going to put that, we're going to write this radical as a exponent. So it's a fraction exponent. So you have 1 over 6. Okay, this index is the denominator. Okay, now here you want to think of those parentheses just as you would think of the parentheses like when you're multiplying x plus 3 and then you have that a number on the outside like 5. What do you do in that case? You multiply. You distribute and multiply. You get 5x plus 15. You want to do the same thing here. So you're going to take that exponent and you're going to multiply it by everything on the inside. So the coefficients and the a. So multiply by all the bases. You're saying, Mr. T, this isn't a base. It doesn't have an exponent. Yeah, it does. Our exponent for 640 is an invisible 1. All right, there's an invisible 1 there. So just keep that in mind. So here this is 640 to the 1/6 power. If you want to try to plug that into the calculator, that'd be cool. Practice. And here 3 times 1/6 is going to give us okay, I really don't like writing that step, but if I wanted to show it at least once. Okay, so yeah, here let's do the 640 to the 1/6 power first. Please let it be a number. Oh, an integer. All right, I'm gonna do 640, a to the b power, decimals, and then 1 divided by 6. Oi, oi, oi. It's not. Okay, so that is a, oh, they're evil. They want us to simplify this. They're crazy. All right, so what we gotta do, horrible, horrible book writers. You want to find the sixth power of 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 2 to the 6, 3 to the 6, 4 to the 6, 5 to the 6, 6 to the 6. Okay, I'm pretty sure it's not going to go that high. So let's plug those in to Desmos. 2 to the 6th power is 64. Hey, I like that one. 3 to the 6th power. 729. Yeah, it's definitely not that. Okay, so we don't need to try the other ones. Because this is too big, right? Our number is 640. So we need to see if 640 goes into 6. Sorry, we need to see if 64 goes into 640. Does it? It does. So 640 divided by 64. 64 goes into 64 once. And we get 64, 0, bring down a 0, you get a 0 here. All right. So you're probably wondering, what does that mean? So basically, I'm going to write this as a 1/6 power because, sorry, 6 root, because I like it like that. So I'm going to write this as a 6 root of 640. I'm going to write 640 as 64 times 10. 64 times 10 is 640. All right. Let me get rid of this. And then the 6th root of 64, we don't need to show this. You don't need to show that step, but I will. So the 6th root of 64 is 2. How'd you get 2? It's right there. 2. 2 times the 6th root of 10. And here, so we're done with that. Yay. And here we have that 3 divided by 6 power. So 3 divided by 6 is 2. Okay, 1/2, sorry. So it's 1/2. Okay. Now, however, if you leave it like that, you're going to end up with 2 times the 6th root of 10 times the square root of 8. And you don't want that. You don't want 2 different radicals. So we're just going to get 1 radical. Okay, how do we get just 1 radical? Don't do anything to it. So you keep it the way it was. So you just keep it as the 6th root of a cubed. That's all. And now we can extend this radical because they're both the 6th root. Got it. Yeah. And I'm going to extend that out just like that. And I'm going to put the a cubed inside. And that's it. All right, so if you want to... all right. Sorry, something smells good. Something just wants something in the microwave. All right. So, yeah, if you want to try 20, feel free to. All right. And let's do 22. And this is probably going to be the last one. I don't know. All right, so we have the 4th root of 27. Then a cube root of 81. Why did I do that? That's weird. Okay. So the 4th root of 27, there's not going to be any 4th root of 27. 2 to the 4th is going to give us 8. 3 to the 4th is going to give us 81. Okay. Wait, that's not right. This is 16. Okay. Yeah. So there's no square root of 27. Sorry, 4th root of 27. So because of that, we can't really do anything with that. All right. Now, I think what they're trying to do is they're trying to say this, hey, 27 and 81, those are all, you can write it as 3 to the power of something. Okay, which is true. 3 to the 3rd power is 27. And 3 to the 4th power is 81, which we just saw. So you can write this as 4th root of 3 to the 3rd. And this one can be written as the cube root of 3 to the 4th. All right. Why did they do this? So the way we want to do this is we want to write these as fractions. So this is going to be 3 to the 3/4 power. And this is going to be 3 to the 4/3 power. Okay, notice that we have the same base, which is what we want. And since we're dividing, when you multiply, you add. When you divide, you subtract those exponents. So we have 3 to the 3/4 minus 4/3. And I'm going to write it here on the side. 3/4 minus 4/3. All right. So it's probably been a while since you did that one. I can show you let me just show you the regular way. So you just multiply by each of the denominators. So here, our denominator is 3, so we're going to multiply the other one by 3. And here, our denominator is 4, so we're going to multiply the other one by 4. So 3, 4, and 4. Okay? So just multiply by the other denominator, top and bottom for each. 3, 3, 3. And when you do that, you get 9/12 minus 16/12 equals negative 7/12.
For a long time, they called it having like a white picket fence, having a hole with a fence, right? I don't know why. I think the son having a dog.
All right.
But show the two-child house.
And there we have
For a long time, those were the minimum.
3 to the negative 7/12. And again, if you want to make that positive, which you do, put that to the bottom there. All right.
For a better life. A better life. Having a home. Better weather.
And then we don't want a radical in the denominator. So oh man, they are brutal here. Okay. So what we're gonna do is we're gonna multiply this. And we want to get rid of this radical. So we're gonna multiply it. Be prepared, you ready? We're gonna multiply it by the top and the bottom by that same radical. Okay. But what radical? We want to multiply it by to the 12th. All right, so here, what we're doing is we're actually going to have to multiply it by that same thing 12 times. You're probably thinking, you gotta be kidding me. No, I'm not. Okay, so you're going to multiply it by 12 times all together. So basically, there needs to be 12 of these. Okay, why 12? Because it needs to cancel this out. So there needs to be 12 of them. So we're actually multiplying 11 of them. So 11 times 7/12 is going to give us 77/12. Okay, so we're going to multiply the top and bottom by 3 to the 77th over 12. And on the bottom, denominator, so on the top we have 3 to the 7/12 over, on the denominator we have 3. Basically this becomes 3 to the 7th. Okay, because 3, they'll become 84 over 12, and that simplifies to 7. So 3 to the 7th. Okay, Now, I'm going to do this on the top here. You ready? We want to simplify that. So 12 goes into 77. 12 goes into 77. 6 times, you get 72. 77 minus 72 is 5. So that's our remainder. That's how much remains inside. So this is going to be the same as 3 to the 6 times 3 to the 5/12. So that remains with the fraction, the remainder, all over 3 to the 7th. So 6 minus 7, 3 to the 6 over 3 to the 7th equals 3 to the 6 minus 7 is 3 to the negative first, which is 1 over 3. So this is 1 over 3 and 3 to the 5/5 power, and so the 12th root of 3 to the 5th. And that is that. Horrible question. All right, let's put that in the notes.
Yeah, you would take it more generous, right? We're having a conversation about.
All right, and there we go. So that's it. Now this one, I did want to go over this one, but it's a word problem, and it's not too bad. It's actually an easy one because we have that equation. So basically, you just want to label like which one is which, and then plug those into those values. Okay. I won't do it because there's not enough time, but there you go. All right. So that's it. And yeah, we'll go on to 0.5 tomorrow.